Hello everyone. We'll continue yesterday's session where we'll be talking about Numpy basics today, and we'll be going through some very important concepts of Numpy, and then later on we will try to complete one small practice on Numpy. So I have opened my Google Colab and I have opened this notebook Numpy basics. So I'll start by importing Numpy. As we all know how Numpy is imported, import Numpy as NP. So let's run this cell. I'm creating an array of a two-dimensional array of int32 data type.
So guys, you can see we can mention D type in the array parenthesis. So it will indicate the type of numericals that are to be uh, inside the array. So for example, if a lemon converts that thing into float, you will see that the array will then come, like, if you print it, it will come in decimal format.
See, there is a dot after everything. So I can have 1 point, for example, I'll show you here 1.5. I can store these values here. See, there is 1.5 here. But if I make it in 32, it automatically gets
Now that
converted to 1.
1.5 will look like 1 and the 0.5 will look like 0.
Yes. Only the integer part is counted, right?
Yes.
Okay, so now then there is another function or variable we can say dot shape that will always give you the shape of an numpy array. So the shape consists of shape is the shape variable will return you a tuple, and the tuple will tell you how many number of elements are there in every dimension. For
So the
example,
first thing shows you the rows and the second one shows you the columns.
yes. So there are two rows and there are three columns. What if there were three? It was a 3D array. What if there it was a 3D array somewhere? Do you know?
If we change it, we will make it a 3D array. What it will do is it will uh, break the current array and it will, okay.
I'll try creating enter.
What you're doing is you're creating it. We can just reshape it. No?
Okay, okay, okay. Yes.
Reshape.
There is another function in this thing in
Yeah,
NumPy
we
that
can
is you dot
function
reshape.
reshape, and we can let them know what kind of shape we need from it. For example, let's count. There are 5 columns, so 10 elements, right? So what we can do is we can either make it as 5 2 or 2 5. That is the only option we have, or else it won't be suffice because there are 10 elements. We need to divide it equally. If lemon were to add it or make it around 12, lemon try making it 12. Just add one elements too.
I'll add one other element here.
Yes.
So I'll be running this.
Now
Take the
see,
shape
now
here.
this,
Take the shape here. See, there are
so
two and six columns.
we can make it into as many shape as, for example, we can make it as 3 4. Try doing 3 comma 4. No, first let's try reshaping it in the 2D format itself.
Okay, okay.
Yes, let
So
them
four
understand.
comma three. That is fine.
4 comma 3 will do.
Yes. Then I'll print the array.
Now if we see, now we will have 4 rows and 3 columns.
No, so I don't change. Okay, okay. Sorry. The yes. So this concept, what happened right now? This is about the views and copies. I'll be explaining it later. So just hold on. I'll be explaining why this thing was printed here. Currently, I'll print this thing. See,
Yes. So because array of reshape was not assigned to any variable, direct changes to the array. It just made for the temporary purpose. If we had stored and given and assigned this value uh, variable, and we had then printed, we didn't print it, we would have got the desired output, but we didn't. So here is one more thing for you guys to learn, that when we use some function, we have to make sure that we are making direct changes to the uh, original array, or they are just doing it for the temporary basis and we need to store that value somewhere.
Yes, this function returns a copy. This function will return a copy. If you don't save it in the array, or if you don't save it anywhere, it will be just as a copy. You can either view it or you can like, change it. But any modification made to this copy won't affect our array until and unless it is saved in this format. It is assigned in this format. Okay. So I won't assign it right now, as I'll be getting back to that topic later. Coming back to our shape thing. So here you saw how I reshaped our array to 4 comma 3. So this array was having 2 rows and 6 columns. Now I have reshaped it into 4 rows and 3 columns each. So 1, 2, 3, 4, 0, 10. This takes place in this manner: 1, 2, 3, first row; 4, 0, 10, second row; 6, 7, 8, third row; 9, 0, 11, third, fourth row. Okay. Now even if you want to make this array from 2D to 3D, no issues.
We can make it as 2, 2, and
2,
4.
3, 2, 3, 2. I guess that
Yeah,
works.
yes, 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 yes.
So
It will do.
your calculation went wrong, I guess.
No, no, I said 2 to 3.
Okay, okay, yeah, yeah, 2 to 3. Even that was, even that was. So
Hmm.
see, this is a big array that I have. It is having two this thing, 2 rows, 1 and 2. Then the inner array that is having 3 each. So 1, 2, 3, and 1, 2, 3. Then all the inside arrays will, the core arrays are
Have
having
two
two
columns.
two rows each, 2 columns each, sorry for that. So 1, 2, 3, 4, 0, 10, 10, 6, 7, 8, 9.
So the basic thing to keep in mind is, whenever you are reshaping things, make sure that the multiplication of those numbers are equals to the number of elements you have in a particular array. That may be an array of arrays, or that may be an just a simple plain array, 2D or 3D, whatever. Just make sure the multiplication is equals to the number of elements.
Okay, so man, even these numbers are having this thing, like even the multiplication of these three numbers is the same. Let's
Yeah.
try running this.
Yes.
See, here you can see two big arrays, then six having 6 rows each and 1 column each. What actually this thing did was just transpose the array, like, from horizontal to vertical.
Yeah. So when we add the element, one more dimension, or single dimension, then we get the transpose of it. You can write any.
Yes, you can check the dimension of that thing here. Uh,
Again, we'll have to first we will have to do this thing. Store it
uh,
in a.
no, no,
Uh,
no.
okay, huh, sorry, my bad.
Okay, so moving on, the data type. As we have discussed the data type earlier, here it's in 32. Let's run this thing and check. The data type is in 32. Let's change it. There are many data types. Like there is in 16, in 32, in 64, float 16, float 32, float 64. It's nothing but just the precision value. Like 16 will have less precision, 32 will have more precision, 64 will be having the most precision. So it's just that thing. And if you want to save space and you want to decrease the computation time, just go for 16. If it is not necessary to having big values like in 64 and that stuff.
For example, if you're using numbers from 1 to 100, you should just go for in 16.
Yes,
If you're
like
going above
see,
100 or somewhere, use 32.
there was no loss. I did it in 16, that saved, that reduced the space of this numpy array by half almost, and there was no loss here. So you can see.
So as a coder, we should always keep in mind that we're optimizing the code wherever possible. It may be space, it may be time.
So now we'll check how to calculate. Like, even I don't know how how much space a numpy array is taking. Check how the space consumed
By int34
by
and int
numpy array.
numpy array is something it is compressed.
Check numpy array and memory size. Let's go here. Memory size, please. Item size into size. Yes, here we'll try this function. Size, that is the number of elements
Right.
present here, into array
That's okay.
one dot item size. That is the size taken by every element. That is the memory occupied by every element. So
But I
just
guess that will add the numbers.
uh, that is 24,
It
right?
added the
No, no, no. It didn't add the numbers. Every
but it will
in
multiply the
16.
addition. My bad. I saw it as addition.
No, 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 no.
I, I thought you were showing the two numbers as string value. That is what I assumed that you are using the plus sign for. And okay, my bad.
Here. Like earlier, it was showing 24. Then I changed to in 32. So the memory size doubled, and now it's taking 48 bytes. So here you can see how it is taking, how you can save your memory, right? And then we have this option of creating a numpy array or numpy matrix of zeros. Practically you will need it while multiplying or some other stuff like that, when you want to when you want just some empty array or a array of ones. So you use this function np dot ones or np dot zeros and just mention the shape of the array you want, correct? Say for example here, if you want to use, if you want a 2D or 3D matrix, so just put it in a tuple and 2 comma 4, and yeah, bingo, here you have 2 comma 4, uh, numpy of shape 2 comma 4. If you want to add a 1, go for this one. Yeah, here you have a numpy array of ones.
Even what you
Anything?
can do is you can fill the value of ones by giving a comma after that 6 comma 2. After that parenthesis, if you just write value equals to in that parenthesis of 1 in that function itself, in the one function, that is empty one. In the
Correct.
ones in the ones, if you
There is a
that is
empty array of 4 comma 2. There is nothing.
yeah.
Like, it is an array just of zeros. So what is the difference between empty and zeros?
Hello, am I audible?
You are completely audible, Samya. Everyone is able to hear you. So what is the difference between empty and zeros?
See, zeros can be considered as empty, but actual empty can't be considered zero, because sometimes empty means having none value. The value can be none or garbage. But when it's zero, it is completely zero. You can add things, you can multiply things to it, but you can even do the subtraction part. But to the empty, you can't do anything unless you have set a value for the empty set.
Okay, this is worth mentioning. This is worth mentioning. Let's mention this. You can't
Because it
do
varies from
math.
like ID or compiler, whatever you say, it varies from it. Sometimes it gives you garbage a set, sometimes it gives you set of zero.
The same is possible in zeros.
So mathematical option operation that you are talking about, you will see it further in the next. coming blocks.
Yes. So now we have array multiplication. So if you try to multiply two arrays to any random array, we just do you think we have multiplied the same array twice. It will take the it will like multiply the it will do positional multiplication. For example, like wait, I'll print and show you things clearly so that you get it. I'll print array one. Okay. So one will be multiplied by one, like another array. One will be multiplied. The position of one here is 0 0. So it will be multiplied with the other
You
array
can
on position
you can
0
also
0.
try multiplying it with a normal integer. Let's try it with 2. Array 1 multiplied by 2.
Yes. First I'll show you array one multiplied by 2 and then we'll come back. So yes,
Now see,
all the whole array got multiplied by single integer. This 2 was multiplied to this, so we got the value 2. This 2 was multiplied to this, then we got the value 4. Similarly, it was multiplied throughout the array, and then we got this resultant array.
now if you multiply an array, what will happen?
An array with array.
The same array. Let's take the same array.
Running this. Yes.
Now we see it is a square. As you can see, each and every element got multiplied by with itself.
Yes. So it
So
don't consider it as like squaring. Just see it as a positional multiplication. 0 comma 0 got multiplied with 0 comma 0. 1 comma 0 got multiplied with 1 comma 0. In that manner. So
yes,
2 comma 0. And what if we multiply the arrays with two different shapes on it?
I think it might show it might throw an error. Let's see.
Just
I'm
just
not
try.
sure.
Let's try. 6 comma 2. So I might okay. See. It threw an error. You can't multiply 2 comma 6 with 6 comma 2.
I guess my common sense is working fine with Python then.
Yes, you're getting right. You are getting your stuff right. And this
Just
is
wait till I gave an exam now. I guess that has that left some effect on me.
and I am like in general Python there is if you want to like a power a raised to the power b if you want to calculate this, so we in Python we calculate it like a raised to the power b, where a can be and a and b can be any numeric value. So for example, if we have 2 raised to the power 3,
Three.
we will get
It
8.
should give us eight.
So these two asterisk consecutive asterisks mean that we are getting them 2 raised to the power 3. So that is used for power thing. So in the similar way, we can do it for arrays. Numpy arrays are no different. They are a part of Python. So you can consider them an array 1 raised to the power array 1. The similar way we are multiplying it. So we are taking the powers here. 1 raised to the power 1 is 1. 2 raised to the power 2 is 4. 3 raised to the
Three
power
raised to
3 is 27.
27.
4 raised to the power 4 is 256. Again, 0 raised to the power 0 is 1. That's tricky. That is some tricky mathematics stuff. Where are 10 went, man? Let me run this. 10 is missing. Yes. 10 raised to the power 10 is missing. Are you sure?
No, no, no. I think something else has happened to us.
Yeah. The limit. What I was talking about, the limit.
Yes.
In 32 can't store bigger value than this. It cannot store that 10 raised to the power 10. That will be so huge number for in 32. So it said no. I can store this thing.
So
Just
if we
take.
make it 64, then we can observe the change of value. So if
Yeah.
we'll
Shall I
make
try?
array
Shall I
1,
shall I try this thing? Like we'll try. We are converting the array into int 64. Then let's come here. Where are things went?
Make sure you run the blocks, or else the following blocks won't fetch the right value.
Running this. Yeah. Yeah, we have it right now. 10 to the power 10.
11 raised to 11.
11, 11 raised to 11. I don't think that is right. Maybe it might be right. I'm not so weak in maths, but that is not my work, so that is the computer's work. I hope this concept is clear. Like concept, clearing your concept matters the most here.
If you have any queries, you can leave the comments and we will address to you.
It's soon. Like, we'll address it here and there.
We will do it.
And then we have the summation of arrays. You can even use dot sum, but no, my friend Soumya thought using a plus sign would be a great idea, so he used it. So
Sometimes you do the simple thing the right way.
yes, but I would say like if you have a function in NumPy, just go for that function that makes things
Yeah,
sorted. Like that in your mind, you always have like this. I am going to use a function for everything
yes, yes. And eventually it will become an habit of you
using
don't have to
functions.
do
Yes, correct,
the work will come in an automated way to you.
correct, correct. And Soumya, do we have a function for this array raised to the power? Do we have any
No,
function?
I don't think we have power functions, but let's see if Google has our answers. NumPy
Yeah, we have a,
dot power. The function itself is called power.
yeah. See, yeah, yeah. You have a function called power. Will both the things deliver the same result? Let me check. Uh,
When we use functions, we get the additional parameters that we need to set. For example, like you saw there's someone said order. If you have to set the order, you can use the
yes,
function,
yes,
the
yes.
parameters.
There are many things you can work with here. Parameters are like x1, x2, where there are different parameters. Okay, let's pass and see. Do we get same value? Did we? Yes, we got the same value. See, the thing works the same. Mhm. Similarly, for this, we'll get the same value. Np dot sum, np dot sum or array1 dot sum, array1 dot sum. Kind of confusing. Okay, this sum the whole array. This is different. This is different. Addition and summation is different. This sums all the elements of the array. 1 plus 4 plus 1 plus 2 plus 3 plus 4. The summation is 16. Now you have now you can even take reciprocals. Nothing much to tell and nothing much to learn about this thing. Just taking normal reciprocal. 1 divided by 1 is 1. 1 divided by 2 is 0.5. 1 divided by 3 is 0.33. 1 divided by 4 is 0.25. 1
Okay,
divided by 0 is
Lemon, I have been
infinity.
talking to you on a mute.
Okay. Yeah, yeah, it happens. It happens.
So this, what I was saying is, why don't we try this sum dot np dot sum array one comma array one? What
No,
can we get there?
that is not allowed. The sum
Okay, okay,
only.
okay, okay. Let's do the access symbol. If we say no sum, no, keep that something. In that sum, array one comma access is equals to
axis.
Yes. When we give axis is equals to 0, maybe they will do the sum of the rows.
No, 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 no. It is there is a function array add dot add np dot
No, no.
add. See, you got everything.
We are just exploring the parameter.
1, 2, 4, 6, 8, 0, 20. Same values.
All right, let's move on. I guess we should also change the topics.
Mm, this is the way you make headings in Google Colab. Use this thing, and then shift enter. See, it gets easier. Look, here you have the slicing section. Then I didn't make sections here. Okay. Okay. Now coming to slicing. So I created another array. You might be having idea with list slicing in Python. If you don't, I would recommend checking that thing. That things will go. Things are very similar here. Still, I'll explain. Uh, if you slice a particular list, what is slicing? Slicing is just like assume a banana. You are just slicing the banana into two, into three, whatever parts you want. So like you take a knife and just slice the banana. In the same way, you slice a numpy array. So 3:5 says that this is what you use to slice your square bracket include with two integers, the start value, the stop value. Okay. So 3:5 0 1 2 3 from 41 it will start slicing 41 54, but it won't take consider the fifth element, it won't consider 65, it will just consider these two elements.
Consider if it would always exclude the last digit that you will mention.
Yes,
That is how the slicing works.
to n minus 1, like start position and to end minus 1 position. That is how it works.
Now, as we can see here, when we are making this slicing part, the the resultant array that we are receiving is the view of the array. So the people who might have learned SQL in their past might relate to this thing. The changes that you make to the view will affect the original data. So as a further example, if we change array 0 equals to 5 and with then uh, print array 2. Okay, I might have taken the wrong example. Just in no
Yeah,
no, I guess it's right.
it is
Correct,
right
correct,
example.
correct, correct example.
See,
Yes, sorry.
like
I got
we printed the array one here. First array, we sliced it. We got this 41 and 54. You can check it here. We got 41 and 54. Later on, we thought of like, changing the value just of this
the
array. But it shouldn't have affected this array too. It shouldn't have affected it. This is what we were thinking, right? We just changed array and not array two. So we change the value zeroth index value to 5. It changed it in array normal array, but however, it also changed it in array 2. You can check it here because it was view and not a copy. If it is a view, this array is a view of array 2. It is just a part that is shown. It is still referencing to array 2. Whatever changes you make to array will be like will be observed in array 2 also.
I hope you get it. Then we can see the counterpart
avoid
to it in the next
avoid
topic.
that. I have done is I have used this copy function. What this copy function does is that is what I was talking earlier. I'll be explaining. So what is a copy? Copy doesn't. keep a reference to the original array, but it also makes a new copy. It makes a new memory it creates a new memory location and then stores the values there. So we slice the array to 3 to 5, that is like 41 and 54 got sliced out of the array, and we created a copy. They were stored into the memory differently. A separate memory block was allocated to them and they were stored there. Array was stored in a separate memory block. We printed it, 41 and 54 got printed. We changed the values. Now it changed in the array, but it did not change. It did not change it in this thing in array 2. That is, this thing can be noted here. So that is all about views and copies. You might find it a bit confusing, but later, like when you practice it, you will find things easier, and you will get to know how when to use copies and when to use views. Not always copying, creating a copy of everything won't be a great idea, because it will consume a lot of memory, and as a programmer, you'll always want to save memory and not consume memory on silly stuffs. Also, yes, I wanted to mention this thing. There is also another parameter, that is step value 0 to 5, and step value is 2. If you run this, see, one step value is like how many jumps it has to take. By default it is 1, but if you want to mention, you can mention another numeric value, integer or a float value, and it will take that many jumps. So 1, then after that it skipped 2 and then jumped to 3. It skipped 2 elements, 1 2. In the similar way, it skipped 41 and jumped to 54. This is what you can observe here. So keep these things also in mind. These are some small and basic things. And this is, and to access array elements, how can you access array elements? I'll take another example. Array 1 is very accurate. Let's consider array 2. Yes, if you want to access array elements, it is completely same as the list. Array 2 0 1 2 3 41. Yes, we got 41. And in a two-dimensional array, let's reshape this to 2 comma 3. After reshaping it, 0 comma 1, 0 comma 1. You got this thing? Now I try printing. It will print 33. Yeah, it got only 3. Strange. Okay, okay, error 2. Sorry, my bad. Happens. 33.
Happens. No worries.
Now I'll create another array. The same I was telling about. In 3D array, you will be accessing elements in this way. Till you can practice this stuff, you will need a bit of practice. So 0, 1, and 1. If you want to access that element, that is 89. 0 is the first array. Then 1, that is this row. In that first element 0 and 1. So that is this element here. Okay, now we'll be moving on to,
Show them what happens if we don't write 0 and in the 46th one above block what array 2 bracket colon comma 2
this is what you're saying.
remove 0 then put a colon then comma then 2
Yes,
comma colon comma. Yes. Now what we will be observing.
see, it has like if in if you want to do slicing in 2D arrays, it is not that easy. So first you'll have to mention for the first dimension. So that is in our first dimension we mentioned that we want all the rows. We want to consider all the rows, correct? For the rows,
Hmm.
we said we want to
Yes.
consider all the rows. But for columns, we said only we want the second column, the column on the second index 0, 1, and 2. So 33 and 65. This is what we got. For example, I only wanted first row. I only wanted first row and I wanted all the elements. I wanted all the like,
Columns.
columns of the first row. So 1, 22, and 33. This is what I got. So this is for first dimension. This is for second dimension. If we had a three-dimensional array, we would put comma and we would do slicing here. This is how it works. I'll try finding a website for this the graphical representation of this and put it in the description box.
That would be great option, man.
Yeah,
Even I would get to learn so many things.
slicing is kind of new. When it's new, it's kind of difficult and confusing. Not difficult, it's confusing. It's very confusing. Like
Confusing. Yes, yes, it's confusing.
I
Whenever I refer to some code, I am like, okay, what are they trying to write in the code? Okay, then I will have to separate it block by block. Okay, then I get to understand. Okay, this is what they used to mean because right now we are working on small things, right? But when we are working on big projects, slicing is one of the important aspect, I would say.
yes,
For example, in machine learning, while we are using data and we want the accurate data or the correct data to utilize,
and you
then
only want like the data that is required. You don't want to give
yes,
unnecessary data in your memory and try computing those values.
exactly, exactly.
So later we have some more basic functions of NumPy that you might or you might not use it in your daily life as a machine learning engineer, but still it's our work to teach you and get you through these functions too. So we will surely get hands on this. Like there is this function called a range. A range, what does it do? It creates a array of like whatever number you say from 0 to that number. If you specify the initial number, it will create an array from 1 to n to it will create an array from 0 to n. So n here is 6. I'll print it and you'll get an array of 0 to 6 elements. You'll get an array of 6 elements 0 to 5.
Yes, 0 to 5. Okay.
0 to n minus 1. So I'll write it
So in Python, when we use range, it does the same thing as what we are doing in arrange.
creates an array of 0 to n minus 1.
Okay. So is there any other parameter that we can pass to arrange?
Yes, we can pass the starting value.
Okay, let's show them how it's done.
Okay. np dot range. So for example 3 to 9. So it will create an array from 3 to 8, correct? 3, 4, 5, 6,
Correct.
7, 8. It created an array in
So
that.
you see, it is very much
We can
similar
also
to the
pass this. Yes, we can also pass the step value if I want. After every, it would. I would don't. I only want the odd numbers, for example. So you will get only odd numbers 3, 5, 7, and 9 was not
Yes.
included, as you know, in 0 to n minus 1. So I hope that is clear. That is one of the essential functions. Then now we have this thing, reshape. As I have already shown you reshape, but still it's written. So I'll just try running those. We created a long array. What was the size of this array? B dot size. Yes, to get the size of to get the number of elements in an array, just use this function. V dot array dot size. We'll get the size. So there are 28 elements. So these 28 elements can be reshaped in any fashion you want. Here I am using 7 comma 4, so 7 rows and 4 columns. Let's just
As
run
we
this.
can see, our guy, because he wanted to show you the size function, he didn't do the multiplication.
Which multiplication?
7 into 4.
Yeah, that the students here are intelligent and they know, they just grasped it. Yes, you all are intelligent guys. Then there is this arg sort. It will return an array with index of the smallest to largest. So what does default? Spelling of default. Yes. So what it will do is it will return an array. For example, I'll make an array here. I'll make a arr is equal to 'So like it will return the indexes. It will return it will won't return the sorted array, but it will return the indexes of the sorted array. For example, our sorted array will be 1, 2, 3, 4, and 5. So it will return 0, the index of 1, that is 0. It will then the next index, that is the index of 2, that is 4,
3.
3, 3, sorry, 3. The index of 3 is 4. So it will return 0, 3, 4, 1, 2. Let me pass this array here. 0, 3, 4, 1, 2. So that is what I said. 0, 3, 4, 1, and 2. So see, it is returning the array of indices. And the axis is by default 0. That, as we told, axis 0 means it is
So by default
sorting
is
on.
1, we are using 0.
Okay, we are using 0. Sorry, by default it's 1. And 0 means like we want to sort the rows, and 1 would have meant that we wanted to sort the column wise.
Yes. Now, if you axis equals if you do the axis equals to 1, then we will get, I guess, 0 0 0 0 0
No, it will, because there is no array. It
axis.
is not a two-dimensional array.
I thought he might assume and just return 0 0 0 0 0.
However, it will work in the case of D, I guess. Let me check. Let us
Yes,
check.
it
Let us check.
should work.
Let us check. 3, 0, 1, 2, 3. Yes, see. It's sorted in this way. Yes. No, the sorting was done in the same manner.
Axis equals to 0. Now you can see.
Okay, see, it has sorted in this manner, column wise fashion. Column wise fashion. It has sorted all these things in column wise fashion. 0, 1. So 1 is here. Then we have 2, 0, 1, 2, 5. Then 3, 4. Yeah, 4. Then, so it is sorting in column wise manner. Axis 0 is equal to column wise. Axis 1 is equal to row wise. Keep this in mind. And then we have arg min function that will return the index of the smallest element in the array. 23.
23.
Yes, so yeah, yeah, 23 is 0.
And
So
if you want to know the value of it, you can just write np dot value, and you can pass, or you can just write the dot value.
after this,
Try writing dot value. I
is
don't know
there?
whether it's a function or
No, no, no.
no. We can actually get the uh, this thing. I don't remember exactly. We might have to search for it. Yeah, there is.
Uh, okay, okay, okay. It got reshaped. It got
No,
reshaped.
for that thing I was saying that we need to use the value part something. There is a function in numpy.
So yes, we have the this is how I used to do it. Like array and the index we need to pass to access any element. So the index is returned by argument function. So I used to do it in this way. I'm not sure what are you talking about the value thing. Let's try it. Let's try it. What are we here for? Trying every small thing. Np dot value.
No, I don't think value can be used in that way.
Huh,
Uh,
let's see. Let's
let's
see.
try googling numpy value, value in array.
Item. That is item, not value. Dot. But that returns item three.
Item
Returns the
7, I guess, is
number.
not item.
It returns the number of time. I guess something like
No,
that.
no, no, no. It is item, I guess. Then
Copy an element of array to standard Python scalar and return it. It just returns it.
try using it. Dot item arr. No, what was it? No, how was it? How was it used? You are doing 8 dot item. It is not like that, I guess.
Np dot item. No,
No, no, no, no, no.
not the
You're
way.
doing it wrong. Go back to the Google thing. The syntax is in x dot item. So
X
it has to be array
dot
dot
item.
I.
What is three?
Where do you see 3?
This three. What is
See, the
it?
3 is the count na 0, 1, 2, 3. 0 is a
What is
2,
it?
1 is a 2.
0, 1, 2, and this 3.
Yes, yes.
0,
That
1,
way it is
2,
going.
3, 4, 5, 6, 7. That is 0. Okay.
Yes.
0, 1, 0, 1, 2. Okay.
So if we are dealing with a multi-dimensional matrix, we can use this thing dot item to refer to the item, like the any number that we retrieved. Yes.
getting the smallest element. This is how you get the smallest element. This is a trick I learned today to get at the smallest element in an array. And same applies for argmax when we want, it will return the index of the element that is highest. So in B, the element on fifth position is the highest. 0, 1, 2, 3, 4, 5. That is 78 is the highest element here. And you might say that we have reshaped it. So 0, 1, 2, 3, 4, and 5. This is how it takes. So 78. Yes, guys, that's it for today. And we shall get
Yep.
back to you soon tomorrow with some more topics. Having the
Most probably we might start pandas tomorrow.
yes.
We
Otherwise,
do.
if you ask for practice, we'll do those practice things. Okay.
Okay, guys. See ya. Bye bye.
Sayonara, guys. Bye bye. Happy learning.